Well, hello there. Today we're going to answer the question, how do we solve rational inequalities? Well, over here to my right, I have the function x plus 1 over x squared minus 4, and I'm going to set that greater than 0. So from a graph, it's pretty easy to see where this graph is greater than 0. It'd be right here and all of these points. Now notice, where do these functions split from positive to negative? Well, those happen at vertical asymptotes and at X-intercepts. So what we're going to do is we're going to find X-intercepts and vertical asymptotes, and then we're just going to test these intervals in between those to figure out where they're positive and negative. And so for this function right here, we can see that it's from -2 to -1, not including anything because it's greater than 0, and then from 2 to infinity. So the challenge is, how do we do this without a graph? All right, and this is a little bit different from solving. You remember with solving, you multiply through by the LCD and all the denominators go away. We don't really want that to happen. So our first step is to add or subtract using a common denominator. And the common denominator is the LCD. So I think, all right, I know my common denominator needs to be x minus 6 times x plus 1. Well, what is the 4 over x minus 6 missing? An x plus 1. So I multiply the numerator and the denominator by x plus 1. And similarly, I'll multiply the numerator and denominator over here by x minus 6. You see, we're not really changing anything because x plus 1 over x plus 1 is just 1. Same thing here. All right, so after distributing the 4 and the 2, we have 4x plus 4 plus 2x minus 12 is greater than 0. Remember, the next step was to simplify. And this simplifies to 6x minus 8 over x plus 1 times x minus 6 is all greater than 0. All right, so let's look at these last two steps. Find the x-intercepts and vertical asymptotes, and then we'll test the intervals using a sign chart. All right, to find the x-intercept, we set the numerator equal to 0, and we get an x-intercept at 4 over 3, 0. And the vertical asymptotes come from the denominator, x equals -1 and 6. So I'm going to plot all of these on a number line, and now what I'm going to do is I'm going to put this into my calculator and test points in these intervals to see if they're positive or negative. All right, so in my calculator I have the 6x minus 8 divided by, notice the double parentheses with the x plus 1, x minus 6. Okay, I'm going to set it to ask. And then to test outside the interval of -1, I'm going to test -2. And I get a negative number. So now between -1 and 4/3, I can test 0. And I get a positive number. Between 1.3 and 6, I'll test 4. Just any number between there. Get another negative. And then past 6, so 7, I get another positive. So now looking at my sign chart, I can see the intervals where it's greater than 0 would be from -1 to 4/3, union 6 to infinity, the places where I got a positive sign. All right, so let's try it one more time. Here's x squared minus x minus 11 over x minus 2 is less than or equal to 3. And we got to start by making this 0, so I'm going to start by subtracting 3. So it's obvious that we can't add the fractions yet because this isn't divided by x minus 2. So I'm going to multiply by x minus 2 over x minus 2. And that gives me x squared minus x minus 11 minus 3x, and notice it's plus 6 because that was a negative times negative. After we simplify, we get x squared minus 4x minus 5 over x minus 2. And that's nice because the numerator factors to x minus 5, x plus 1, all over x minus 2 is less than or equal to 0. So now we can find our x-intercepts and vertical asymptotes. This gives us x-intercepts at -1, 0, and 5, 0, and a vertical asymptote at x equals 2. So all of these are going to go on my sign chart. Again, now I can just go right here, plug this into the calculator, and test intervals. Once I've tested those intervals with the calculator, I get negative, positive, negative, positive. And because I'm looking for whenever it's less than or equal to 0, I'm looking at these negative signs. And so my answer would be from negative infinity to negative 1. Now negative 1 is included. And then from 2 to 5. Now you might be asking yourself, whoa, 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 whoa. Why did negative 1 get included and 5 get included, but not 2? And that's because vertical asymptotes are never included, because you can never touch the vertical asymptote. All right, and that's how we solve rational inequalities. Today's notes brought to you by the number pi. Goodbye.